The open loop transfer function of unity feedback control system is given by G of S, the phase crossover frequency and the gain margin. The phase crossover frequency is the frequency where the phase of the angle of G of S is minus 180 degrees. That is, the angle of GS is becomes minus 180 degrees at phase crossover frequency. Minus 90 minus tan inverse of omega T1 minus tan inverse of omega T2. Okay, this is at phase crossover frequency omega P. Now this is minus 90 degrees minus tan inverse of omega pt1 plus tan inverse of omega pt2. So this is infinite if we apply tan on both sides. Apply tan on both sides. So this is omega pt1 as omega pt2 1 minus omega p square t1 t2. So omega p must be under root 1 by t1 t2. This is the phase crossover frequency. Here the gain margin is nothing but g of j omega. At omega equals to omega p, we have to calculate the magnitude. This is if I am indicating with a, then gain margin is 1 by a. Okay, so if we substitute omega p in the magnitude, that is g of j omega is nothing but 1 by omega 1 plus s t1 t2 plus s square t1 t2. So if we substitute this one, we will get the magnitude as 1 by t1 and t1 plus t2 by t1 t2. Hence option A is correct. The frequency response of free emphasis and de-emphasis filters of an FM system are as follows. The PSD of the message signal M of t is given as SM of f. Okay. The scaling factor k is to be chosen so that the average power of the emphasized message is same as that of original message. Means after free emphasis, the power contained in the emphasized signal should be equal to the power of the message signal. The power of the message signal is nothing but integration of the PSD over the frequency range mentioned over there. So power of the message signal is I am indicating with PM, which is because here Sm of f is an even function, so I am taking integration from 0 to omega s naught. See here omega 1 plus f by f naught square df. So if we integrate that one to s naught f naught tan inverse of omega by f naught we will get. Okay, this is PM. Here the power of the emphasized signal is nothing but, suppose this is the pre-emphasis filter. Okay, pre-emphasis filter. This is the input PSD Sm of f. Output PSD is nothing but filter, that is HPE of f whole square into Sm of f. Okay, this is the output PSD. That is output PSD of free emphasis filter is k square 1 plus f by f naught whole square this one s naught 1 plus f by f naught whole square. So this gets cancelled. K square s naught is the frequency range over the range mod f 2 omega, mod f omega. So output power is nothing but 2 k square s naught omega, which is equals to 2 s naught f naught tan inverse of omega by f naught. S naught gets cancelled, 2 gets cancelled. Here k is chosen that f naught by omega tan inverse of omega by f naught 1 by 2. This is the value of k. Now see, lambda by 4 long 50 ohm transmission line is open circuited at the load end. The input impedance measure at the other end of the line is approximately. Here we know that suppose if this is lambda by 4 length, okay, it is terminated with a load impedance ZL, okay, which is having a characteristic impedance this. So this is the input side. If we are looking, this is the Zin. Here Zin is for lambda by 4 length line Z0 square by ZL. In this case ZL is infinite, means it is open circuited, because load end is open circuited, ZL is infinite. So if ZL is infinite, Zin is 0. Hence option D is correct. Wave transformer matching is 75 ohm source with a 300 ohm load. It should have a characteristic impedance. So we know that for a lambda by 4 line, the relationship between the input impedance and the load impedance as Zin is Z0 square by ZL. Means we have to calculate the Z0. Zin and ZL are given in the question itself. So under root Zin ZL, that is 300 into 75, here under root 300 into 75 equals to under root this, means it is 150 ohms. Hence option C is correct. Two lossless lines are connected as shown in the figure below. The input impedance Zin at A is where Z0 is 100 and ZL is 60. So we know that this line is quarter wave line, this is lambda by 2 line. So suppose if we are calculating Z in dash, that is Z0 square by ZL, that is 100 square by 60. Okay, 100 square by 60, how much? 100 square divided by 60. This is 166.66 ohms. Okay, but this line length is lambda by 2, means Zn is nothing but Zn dash. Okay, hence option B is correct.
We have to find the variance of the distribution.